Welcome again to your instructional videos for online trigonometry, and I wanted to talk to you guys about identities and how they are different from the definitions of section 1.3. In section 1.4, we deal with the reciprocal identities. First of all, we did talk a little bit about that before. Here's the reciprocal identities. And what they do is they basically help you get answers a lot easier when you have identities to work with. Another set of identities are the ratio identities, and these are the two ratio identities. And finally, what you have is the Pythagorean identities. So that's in table 3, all of which need to be memorized, and especially this one right here. I know these other two are listed, but the one that you really need to use a lot is that one right there, cosine squared theta plus sine squared theta equals 1. Well, let's talk about how these are useful. And what we often want to do is, given, one of the values of one trig function, you perhaps want to get the other trig functions. In this case, what I'll do is I'll write just sine of theta equals 1/4. Okay, suppose that you were just given that much information. The reciprocal identities just allow you really quickly to get the value of cosecant of theta. So now I can obtain the value of cosecant of theta simply by taking the reciprocal of the value of sine of theta. Okay, so that allowed me to get from sine to cosine. From sine to cosecant. Now the question is, how would you get the other four? So what we have is now 2 of our trig functions, and what we would probably want is the other 4. So let's look way down here. The Pythagorean identity allows you to get a bridge between cosine and sine. So I'm going to use this identity right here with the given information. What we have is that cosine squared of theta plus sine squared of theta equals 1. But I just gave you what sine of theta equals, so I'm just going to replace sine of theta with its value. Well, that's going to be then just something to solve as far as an equation. What I now have is this as an equation. I subtracted the 1/4 squared to both sides, and now I have cosine squared of theta equals. And what I get now is 16 minus 1 is 15. Notice that what I had to do was find a common denominator. So the 1 became 16 over 16. And then I was able to do the subtraction from there. So I have 16 over 16, that's the 1, minus 1/16, and I get 15. Okay, for the numerator. So now what we do is we take the square root. Now I want you to notice something, and that is that this is plus or minus the square root of 15 over 16, and that means it's plus or minus the square root of 15 over the square root of 16, but the square root of 16 is 4. So at least that simplifies. The square root of 15 doesn't, because there's no perfect square that divides 15. So what we have is this. But here's the interesting thing, is that I ended up with plus or minus, and I kind of need to make a decision. So here, let's go back. What we were given was actually kind of not enough information. What we have here is that sine of theta equals 1/4, and that really only tells me so much. That is that in quadrant 1, I could have a sine of theta that equals 1/4, which means that sine of theta is positive. In quadrant 2, I could also have a sine of theta that's 1/4. See, that's the thing, is that you don't know which quadrant it's really coming from. Notice that what I'm really analyzing is that sine of theta by definition is y over r. And since r is always positive, the fact that I have 1/4 tells me that my y value is positive. And y values are positive in both quadrant 1 and quadrant 2. But the issue here is this, that it's quadrant 1 or quadrant 2, and so I don't know whether or not my cosine is negative or positive. Why don't I know that? Well, because in this quadrant, all of my x's are positive and all my y's are positive, but in quadrant 2, even though all my y's are positive, all my x's are negative. And remember that cosine is x over r. So what I'm saying is that I don't know which one to select. Down here, when I did the work, I didn't know whether it's positive or negative. So I wasn't given enough information. So what you'll notice is when asked these problems, it'll also say something along the lines of theta is in quadrant, and I'll tell you which one it will be in, and I'll say 2, okay? If theta is in quadrant 2, then what we're going to do is we're going to pick the answer that we came up with down there that's negative. So I would say negative the square root of 15 over 4, right? So that would correspond with this information over here that if x is negative, then cosine of theta has to be negative because it's x over r. So I would have a negative for my answer because it's negative x. Does that make sense? So if I have these two, I have now sine and cosine. I'm going to use the other identities to be able to obtain then all of the other trig functions. So I already have cosecant. Okay, so we have now 3 out of the 6. Now let's get the other guys. So notice that if I have cosine, I can get secant. And I can get secant really easily because secant and cosine, let's go over here, secant is the reciprocal of cosine. And what that just says is that you can just flip over your fraction, the bottom becomes the top becomes the bottom, and you have your answer. So I'll make this the top and I'll make this the bottom. And I took the reciprocal. This is my answer. Well, I do want to rationalize the denominator, so you always want to do that. So I'll really quickly do that. Super easy to do. All you do is multiply top and bottom by the square root of 15. So the value of secant of theta is negative 4 root 15 over 15. Okay, so now I have that one as well. And I'm just using identities to get these answers. The next identity I'm going to use to get my answer is the ratio identity for tangent. So that was found down here. You'll see in this table, tangent, it says, is sine over cosine. So we already have our answers for sine and cosine, don't we? They're right there. So instead of writing sine, I would write 1/4. And instead of writing cosine, I would write the square root of 15 over 4. So now I just do a little arithmetic. You always want to simplify. So I would have 1/4 times negative, and what I have to do, of course, is multiply by the reciprocal. That's how we do divide a fraction. So I'm doing that here, and then these cancel, and I have a negative 1 for the top, and I have the square root of 15 for the bottom. Okay, guys, always remember that you have to rationalize denominators. So here I go, rationalizing my denominator. And in doing that, do you see what you would get? Negative square root of 15 over 15 is the answer. All right. I have 1, 2, 3, 4, 5 answers. I have one more to go, and that would be cotangent. Cotangent is reciprocal to tangent. So I want you to recognize that when we did tangent, I did rationalize the denominator of this equivalent fraction, that one right there. Do you see how I did that here? However, I'm going to actually use this fraction here because if I flip it over, it's in most simplified form. So notice that if you take the reciprocal, if you flip over negative 1 over square root of 15, if you flip it over, then you would get negative square root of 15 over 1, and then I have my answer here. Okay, So as you can just see, I've found all 6 trig functions from 1 sine of theta equaled 1/4. That's all I gave you. And knowing that theta is in which quadrant. This was all I gave you, and you were able, through the identities, to be able to obtain the value of all of the others. Okay. Now, I might mention too that notice that the notation here of squaring, that the 2 does not come after the theta, so we don't write that. But it's understood that if you write it in between the s and the theta, then it's cosine squared of theta actually means the same thing as using parentheses on this expression that I just wrote right here. So if you don't write the parentheses, this does not equal cosine squared theta. What this says here is that you're actually squaring just theta. So these two are not equal. Just be aware of that, that we always put the squaring when we mean to square cosine or sine. You put the squaring in the appropriate spot, which is right after the function and before the angle theta. Okay? Good stuff. So good luck on your homework, and let me know if you have any troubles.